We spent so much time in section 2.3 last time that we need to spend some time in section 2.4 and play some catch up. So section 2.4 is on quadratic inequalities. That is to say, we're going to be taking these quadratic parabolas, excuse me, and we're going to talk about when are they greater than or equal to 0, or strictly greater than 0, or less than or equal to 0, or less than 0. And so we're going to be doing inequalities with these quadratics. So let's talk about how we're going to do that. So this is section 2.4. And the idea is pretty straightforward. Graphically speaking, we can analyze a quadratic inequality based on two features of the associated quadratic function, parabola. One, the zeros, and two, the leading coefficient, A, from the coefficients A, B, and C. So what are we talking about here? If we take a look at a random graph of a parabola, I'm just going to just draw some stuff here. Here we go. Here's f of x. And suppose we wish to know the values of x for which f of x happens to be greater than or equal to 0. Well, that is the values of x where the curve is equal to, oops, that's not supposed to be straight, where the curve is has its x-intercepts, or where the curve is above the axis. That's what it means for the y values to be positive here. So this implies the y values are positive or equal to 0. So what do we really want? Well, first of all, we want our zeros here. That'll be these points. And then in this particular case, because the A value is greater than 0, this parabola opens upward, and it's always going to be above the axis on the outside of its zeros, and of course equal to 0 at its zeros. So what we're what are the x values for which the parabola is above the x, right? So or equal. We want the values of x for which the parabola intersects or is above the x-axis. Now, into this inequality here. Let's see. If we take a very similar scenario, for f of x not greater than or equal to 0, but just strictly greater than 0. We actually want almost the same thing here. But, whoa, undo. Don't lose all of that. Nope. So in this particular case, because we want it greater than 0, we note f of x is not equal to 0. So in this particular case, we do not want to include the x-intercepts, but we still want it greater than 0. So we're still going to include the values of x for which the curve is above the axis, but not the zeros themselves. And so in this particular case, we would be talking about another broken interval, but this particular broken interval would not include the zeros themselves. So again, in a slightly different scenario, as we duplicate this scenario, let's see here. This time we'll talk about a different inequality. Let me just duplicate this again here really quick. If for f of x less than 0, this time we want the x values for which the curve is below the axis, right? So in this particular case, since it's less than 0, we don't want to include the axis, but we do want the region in between our zeros. And so in this case, we would not have the zeros themselves, but we would have the interval in between the zeros. And then finally, the only other scenario is for f of x less than or equal to 0, in which case we do want to include those x-intercepts. So we would use solid dots. And then we still want to be less than the axis because we're less than or equal to 0. And in this particular case, we would get a similar interval. Oh, that's not what I want. So going back again here, we have 4 scenarios. If we are, this is just for if a is greater than 0. Obviously, if a is less than 0, this coefficient, then the parabola is flipped upside down. We need slightly different regions here, but the basics are related to whatever this inequality is. That's key. And then, of course, where are your zeros? And then is your parabola opening upward or downward? And this classifies the intervals that we're looking for here. So here, our answer is an interval. And we must write our answer in interval notation. So if you're still having trouble with interval notation, you got to get on top of that. Here we want the values of x for which the curve is above the x-axis only. In the next scenario, we want all x values for which the curve is below the x-axis. And then finally in this bottom scenario, we want all values of x for which the curve is below or on the x-axis. So let's take a look at an example.